We can look at some of the other questions in your homework. So number 5, if we are looking at that question. So looking at your homework, I kind of started, I thought if there was going to be questions, that there would be questions possibly starting with number 7. I wasn't anticipating 5 and 6. Number 5 tells you when you are looking at the, when you look at that information, it says, graph the relationship that is not proportional and discuss why. So if I was looking at number 5 in your homework and you have this side in inches. So it says here's the side of a square it looks like in inches. So side of a square, so is everyone looking at number 5? You have side of your square, so this is in your workbook, and so help them out in your notes and workbook. So your other one is the workbook, if you find it. Did I give you 2 of them? Yep. Okay. So you have side of the square, and it tells you these are your inches. And then it says, what's the area? If I am looking at this, and the side of the square is 1, what is the area going to be? 1. And if the side is 2, the area should be 4. The side is 3, 9, 16. And 16. So this is the table. This is what you should have filled in for your table in number 5, and then you should graph it. And when you go to graph this in number 5, you need to set a constant scale. So depending on your scale, I think, were you able to go all the way up to 16? Yeah. So you're going to have from 1 up to 16. And over here you have the 1, 2, 3, and 4. And this should be the side length. And this should be your area. And it does not make at 0 it was 0. At 1 it was 1. At 2 it was up to 4. And it should have made a curve, is what I should see when I'm looking at number 5. And then in number 6 it says, well, state in words the proportional relationship. If you are looking at number 6, you simply should have noticed that it costs, if you are looking at that for 1 ounce, it looks like it costs 50 cents. So something along that line for number 6, as you were looking at that one. The next one is question number 13. As you are looking at number 13, it says, Milo drives through the toll booth every 30 minutes. So every 30 minutes, he has through 4 toll booths every 4 minutes. So, which means if we have, as we are looking at this one, we are going to have our minutes down here, and we should have our tolls over here. So as we are taking a look at that one, we have our minutes, and we should have our tolls. And as we look at that one, we want to start off with at 30 minutes. So we're going to have 0 being here, then we have like 30 minutes, then we're going to skip 1 and put 60 and 90. And our tolls going up, we probably want to go with, you could possibly even go with 1, 2, 3 and have 4. So at 0, we were at 0. At 30 minutes, you're at 4. Then you're going to have 8. Then you're going to have 12. At 60 minutes, if we keep going, 8. 90 is 12. And so you should have something like that. And it just depends on what you use for your numbers. Okay? If you use 30, 60, 90, yours is possibly, depending if you went up by 2s, this is going to look a lot different. Okay? As you looked at these, remember, you are looking at for each one, as you increase 1, how far did you go up? So as you looked at questions 9 and looking at some of those. If you do have questions, make sure you are checking that we answer those. If you did not complete yours, make sure you get that done through E2. And if you would now turn in your notes to E3. So E3 in our notes. Oh, Drew, again, I had a good break. E3 notes. Thanks for asking. Proportional relationships and unit rates. So, we've already talked about what our proportional relationships are. I appreciate you trying to get us off topic, but we're going to keep going. We're going to interpret our unit rate as a slope. We're going to keep using the graph tables to determine what that unit rate or slope is as we look at these different relationships. Is everyone here on E3? Come. So, we are going to look at this first video kind of like we did before. As we watch the video, you should be filling this part in. So, what is the unit rate as we are looking at this? So, you're going to look at this one, and you should be able to fill this in as you are watching this first video.
How fast is this car traveling? What is the unit rate in miles per minute? In this lesson, you will learn to find a fractional unit rate by using a graph. You've already learned how to find a unit rate from a graph in some cases. For example, for this graph of a proportional relationship, you could find 1 on the x-axis and see directly that 1 pound costs $3. So the unit rate here is $3 per pound. Now in this lesson, we're going to be needing to divide in some examples where we don't get an integer as an answer, such as what's 3 divided by 7. A common mistake is thinking that you always need to give your answer as a decimal. In fact, it's often much more efficient to give the answer as a fraction, because 3 divided by 7 can just be written as 3/7. Keeping that in mind, let's move on to see how that can help us find a unit rate from a graph. What's the unit rate for this proportional relationship? Well, the quickest way is often what I reviewed earlier, to just find 1 on the x-axis. The problem here, though, is that when we look up at the graph, we see that we're not on an integer. The y-coordinate corresponding to 1 as an x-coordinate is not a whole number, so we can't tell precisely what it is. Fortunately, we know a few other ways to find the unit rate. One way is to pick any ordered pair on the graph, such as this one, and look at its coordinates. This ordered pair tells us that in 5 minutes, you can travel 3 miles in 5 minutes. From that information, we can find the unit rate.
So you should be able to fill that in, right? Right in your notes?
Are just as good in this case as decimals. So our answer is 3/5 of a mile per minute.
So when we're looking at that, those are the answers that we want to have in as we are looking at ours. So if I was looking at yours, and this is something that I often notice with some of you, is you want to always change everything on your calculator to that decimal, like they were just talking about. And you can leave both of these simply as going here at 5, and we're using this 1 point, and finding that 1 point. Because at 1, we can't really see what it is. We can't tell if that's 3/5 or 0.5 or 0.56. So using this point is a much better point for us to use. Okay? So that should be filled in your notes. And as you take a look at the top of the next page, we're going to watch this other video, and it asks you to answer both of these on this page that we are going to look at. So as you watch this second video, kind of take a look at these, and you should be able to answer these next two.
Did you know that equations can have pictures? Here's a complicated equation, and here's a picture. You might study why this equation.
That'll come up in Algebra 2 and Advanced Math where you're
Let's
looking.
look at a simpler equation like this. What kind of picture does it have? In this lesson, you will learn to understand proportional relationships by relating their graphs and their equations. Let's review what you already know about equations for proportional relationships. Here's a proportional relationship, $8 for 2 pounds of potato salad. You already know that the unit rate can be found by dividing. In this case, it would be $4 per pound. To write an equation, you pick a variable for the independent quantity.
Always your independent on our x-axis, okay?
And you would need to multiply that variable by the unit rate, by 4. 4W would give you the cost of any number of pounds. You take a second variable to represent the dependent variable, the cost in this case, and you set 4W in this case equal to that second variable. So the equation is that the cost is equal to 4 times the number of pounds. There are a couple of common mistakes we need to be careful about. Suppose you're talking about 3 miles per hour, and suppose you use t and d as your variables for time and distance. Which one is the independent?
So this is that next part down.
Goes on the x-axis. Well, in a unit rate, the one that is the after the word per, the one that we have one of is the independent variable and goes on the x-axis.
So that's always your independent.
So time, or the number of hours, goes on the x-axis. One more thing to be on the lookout for. If you're writing the equation, which of these is correct? Be really careful that you multiply the correct quantity by 3. In this case, we want to multiply the number of hours by 3, since it's 3 miles per hour. So this is the correct equation.
So as you are looking at these,
First, let's learn how to.
so as you are looking at yours, one of the things you're going to notice on here is that we put down that how do you, after you watch this, how do you make sure, how do you test to make sure that you've done this correctly? So there's 2 ways of checking, so it's kind of like our check of our equations. You can show how to test an ordered pair. So they gave us the one that at 1, we were at 4. What if I wanted to go to 3 pounds? If the weight is equal to 3 in this equation, right? So we're going to go to this equation. If W equals 3, our cost should be 12. So we're going to take 4 times 3, it should be 12, right? So my ordered pair that I'm looking for that makes this true should be 3, 12. And if I go to 3 and I look at my point, 3 and I go across, I see the number 12. So 3, 12 works. If I wanted to check 4, it should be at 16, right? So I can use those to check and see that I did them correctly. Same thing on this one when you were taking a look at your, as you looked at your graph, you should have had, if you did not fill yours in, if you would please make sure you graph this at 0, it was 1. 1 hour we said was 3, so please put a dot at 1, 3. At 2 it should be at 6, so this is on that bottom one. 3 would be 9. And if you were going to continue that. And what we always want to do is make sure that as we extend our line that we are making a nice straight line. I will have rulers for you to use, but I will also ask that sometimes you can use like the edge of your book or the edge of another piece of paper or something along that line. And then we want to extend this one because at this point, it is continuing at that same rate. So putting an arrow on the end, not an end point. It's not a segment, it's a ray. So make sure you have that ray, okay? So this last one is asking us which one is a better deal. So we're going to look at this last video, and after we watch this last one and answer these last few questions, we will get you started on your homework.
Charges $2.50 per pound.
Top of that last page, notes.
Comparison is easy. But if instead I give you a graph showing store decide which store is offering the better buy. In this lesson, you will learn to compare proportional relationships by comparing their unit rates.
So we're always going to look at what the unit rate is.
Let's review what we know about finding a unit rate. We know that if you have a pair of numbers, like $6 for 2 pounds, you can divide and get $3 per pound. We know that from an equation for a proportional relationship like C equals 3W, the number in the equation is the unit rate, so 3 here would be the unit rate. And we know several ways to find the unit rate from a graph. One of the easiest, when it's possible, is simply to find 1 on the x-axis. In this case, 1 pound corresponds to $3, so the unit rate is $3 per pound. When answering the type of question that we're going to answer,
So it's really careful as you look at the two different things.
For example, which of these two stores offers the better buy? We can tell that $3.50 is less than $4. Do we want fewer dollars per pound, or do we want more dollars per pound?
Fewer. We definitely want fewer.
In this case, better buy
Generally.
means fewer dollars per pound. But we've got to be careful not to automatically pick the larger number or the smaller number without thinking the situation through. Okay, so which of these two stores offers the better buy? Store A's pricing is represented by this equation, store B by this graph. Let's figure it out by comparing the unit rate. The unit rate for store A is $2.50. $2.50 per pound. Store B has a graph. We can find the unit rate by finding 1 on the x-axis. We see that 1 pound costs $2, so the unit rate is $2 per pound. Since we're talking about which is the better buy, the answer is going to be the store that offers, that costs fewer dollars per pound. So store B
Should be circling store B for that one, right?
$2 is less than $2.
I want you to graph store A.
By the way, this is what the graph of store A's pricing would look like. Notice
I want you to graph store A in that when you went to 1, it should be at 2.5, right? At 2, you should put a point at $5, right? You're going up another at 3 up to $7.50, right? At 4, you should be at $10. So plot that one also.
that it's steeper than store B's graph. That's because you're paying more dollars at store A for every pound. Which of these trains is traveling faster? Train A travels 8 miles in 5 minutes, and train B's distance and time are shown on this graph. Again, let's compare unit rates. For train A, we can divide 8 by 5.
Please
and
make
we get
sure
1.6 miles per minute.
that we put it right like that.
As a decimal rather than a
So this 8.5, change it to 1.6 miles per minute. And now go to your graph, and since we can't tell exactly at 1, what is the first number that we can tell at? How many minutes? At 3? And at 3 it looks like it is 5, right?
fraction because decimals are going to be easier to compare.
So compare those two.
Train B, the easiest way is going to be to pick an ordered pair. Notice that if we looked at 1 on the x-axis, it's hard to tell what the corresponding coordinate is because we're between.
What should it be? Use your calculator if you need to divide. We want to put it as a decimal also.
5 miles are traveled in 3 minutes. Dividing 5 by 3, we get a unit rate of 1.6 repeating miles per minute. Now compare. Faster.
So when we look at these two, this train is going 1.6, this one is going 1.6 repeating. Which one is going faster? Train B, definitely, right? Whereas when we are looking for a better buy, we went with the cheaper one, right? Now when we're looking for who's going faster, we're looking for the one that actually has the bigger number rather than the smaller number, as you are looking at that, okay? So you should have filled in your notes for these last two. As you were looking at this, train B being at 5 divided by 3, which was the 1.6 repeating. So train B was faster as we were looking at that. I would like you, if you would please turn in your homework. I have scissors up here for the E1 and E2. Today, before you leave, I would like E1 and E2, those cut out and handed in. We are going to look at E3 right now. As you take a look at E3, in E3 there are 4 pages of that. So as you look at that first question, it's just asking you to find the unit rates in 1, 2, and 3. Okay? The easiest way to do that is find your point. If you can't find at 1 exactly what it is, the first one that you can find, so in number 1, you should be taking those numbers and divide it. Remember, you can leave your unit rate. You want to make sure with rates that you tell me what you're talking about. So I should have miles in the numerator in this case, and I should have minutes in the denominator. Make sure you label your unit rates, okay? So you're doing those first ones. The next ones, again, you're just asked what is your unit rate. If you take a look at question number 6, please look at number 6 right now. In number 6, it is asking you to use the equation. C equals 5W. So as we look at that equation, can we tell what our unit rate is? C equals 5W. The unit rate is what? I'm looking for my unit rate. What would you say it is equal to? How much are we paying for each, in this case, pound? $5. So the unit rate is $5. That's why in our equation it's the 5. $5 per pound. Now in the video it said the per is always our independent variable. So that's our X, right? X is going to be pounds. That's our independent variable. The dependent, what depends on it, is our costs over here in dollars. And you're going to want to set your cost as you are looking at that. You might want to go up every 2 by 5. You might want to go up by 1s. You can decide. Okay? So you are going to finish this assignment. And I think tomorrow we will take a quiz on E1, E2 with unit rate instead of today. So there are questions 1 through 13, so make sure you do all of those. Get started. You can work with your shoulder partner where you're sitting. Yeah, get started. If you have questions, ask. I'll try and help you out.